Greetings, Science Fam. Today we're going to introduce something called the combined gas law. What it's doing is if this is an actual gas that's going to go through some changes, we know that a gas is dramatically affected by its pressure, volume, and temperature. So for the combined gas law, if the moles of the gas are going to stay constant, you can use this relationship. The relationship states that the starting pressure, the starting volume, and the starting temperature can all be related and proportional to the final pressure, volume, and temperature of a gas. So when you look at this equation, PV over T equals PV over T, we can plug in for 5 of these 6 variables and we'll be able to predict what the other change would be to the gas. We know that pressure, volume, and temperature all dramatically impact each other when talking about a gas. The one thing we do have to keep in mind is that temperature needs to be measured in Kelvin. All right, we don't want to use Celsius, we want to use Kelvin. The reason Celsius can go into negative degrees and we don't want that. So Kelvin's lowest possible temperature is 0. By the way, a quick reminder, Kelvin is just the degrees Celsius temperature, and you add 273 to it. All right, so now that we've introduced the combined gas law, let's do a couple practice problems to see how we plug it in and solve for it. So here we have some combined gas law problems, and we want to remember that the equation for the combined gas law is P1 times V1 over T1 equals P2 times V2 over T2. So let's go ahead and get used to not only plugging this in, but also we need to really understand what the units are for pressure, volume, and temperature so that we can pick them out and plug them in. So number 1 says if I initially have a gas at a pressure of 12 atmospheres, so my starting pressure is 12 atm, and it's a volume of 23 liters, so my starting volume is 23 liters, and a temperature of 200 Kelvin, good, my temperature is already in Kelvin, so that's perfect, I don't have to convert that. So I have my P1, V1, and T1. What happens when I raise the pressure? So this is a new pressure. Let me do a new color there. A new pressure of 14 atmospheres. So if you look, pressure was now raised by 2 atmospheres, and the temperature is increased to 300. So my new temperature went from 200 to 300 Kelvin. We want to know what the new volume of the gas is. So that's what we don't know. So we can use our equation P1 V1 over T1 equals P2 V2 over T2 to solve for that. So let's go ahead and do that. My P1 is 12 atmospheres. My V1 is 23 divided by 200 Kelvin. Now, as long as the pressure is the same on both sides, you can use any unit for pressure. So atmospheres will work just fine here. The volume we don't know, I'm going to leave that as my variable, and then 300 goes on the bottom. Remember, we always need Kelvin on the bottom for that. So there's a bunch of ways you can solve for this, but many of my students seem to like the crisscross method or cross multiply. So let's do that. That's going to be 12 times 23 times 300 is equal to 200 times 14 times V2. Okay, perfect. Let's not mass that out, but calculate that. 12 times 23 times 300 ends up getting us about 82,800. And that's going to be equal to 200 times 14 gives me 2,800 times V2. Now that we have that, let's solve. I just put a little box to clean things up so we can see better. But let's take that. We're going to divide both sides by 2,800. By doing that, we're now going to get V2 all alone by itself, which is great. And when you take the 82,800 and you divide it by 2,800, you end up getting about 29.57 for your answer. That's great, but let's take a look at what are going to be the units. So for volume 2, the volume is going to be the same as volume 1 for the units. So that's liters. So we're going to need to put liters in there. So what happened? As you increase the pressure and increase the temperature, you also increased the volume from 23 to almost 30 liters. You can see how all of these play a different role and part in the gas. But there you go. That was problem number 1. To give it a try, let's try one more just to get the hang of it. Question number 2 says a gas takes up a volume of 17 liters. So right off the bat, I know that my initial volume is 17 liters. It has a pressure of 2.3 atmospheres. So I've got a pressure of 2.3 atmospheres, ATM, and a temperature of 299 Kelvin. All right, so my initial temperature is 299 Kelvin. So right off the bat, for my combined gas law, P1 V1 over T1 equals P2 V2 over T2. I've got my whole left side done. Let's move on. If I raise the temperature to 350 Kelvin, so that means I'm going to have a new temperature, and I lower the pressure to 1.5 atmospheres, so my new pressure went from 2.3 now down to 1.5 atmospheres. We want to know what the new volume is. That's what we're looking for. So that's our big question mark. Well, now that we have that, let's plug in to find out. So we're going to do P1 V1 over T1. So it's going to be 2.3 times 17 divided by 299. And then on the right side, P2 V2 over T2. P2 is 1.5. V2, I don't know. I'm going to solve for that. And T2 is 350. Now that I have that, I can do my crisscross method if I want, which I'll do. It just seems what a lot of students like to do. So that's going to be there. And then 299 times 15 times V. Now that I have that, let me rock the numbers out in my calculator. So for 23 times 17 times 350, it looks like I end up getting 136,850. And for 299 times 15, I get about 4,485. Now that I have that, I do need to get volume by itself, so I'm going to use algebra, divide both sides by 4,485, and throw that in my calculator to see what I end up getting. So 136,850 divided by 4,485. I end up with a volume of 30.51. Question is, what are my units? Well, I'm looking for volume, so I'm going to look for the units it started with, which was liters. So that's going to be my final answer, 30.51 liters for the volume. So it looks like as we drop the pressure and increase the temperature, we ended up increasing the volume as well. Since we dropped the pressure, it looks like it had more room to spread out. Plus, when you heat up a gas, it also wants to spread out. It has more energy. So this makes sense that the volume went up. All right, friends, that was the combined gas law, taking 3 variables that express what a gas is and using it to our advantage when the moles don't change to set those proportions equal to each other. All right, best of luck, science fam, and we'll see you in class.